Chapter 4, describing data, still describing data, using graph and describe the shape of data. First, dot plot. Using dot, such as using dot describe data. So 23 is on here. 27 here. Another 27 here. 27. So another 27 pile up. So using that and then pile up if multiple the same numbers like this. Dot plot is to develop a dot plot. Each observation is simply displayed as a dot along a horizontal axis and number line indicating the possible value of data. And then if there are identical observations, the same number, or the observations are too close to be shown individually, the dot are piled up. So that plot looks like this. So using excuse me, that, then we can see data shape distribution. That is dot plot. Stem and leaf, similar to dot plot. Instead of dot, we use number. So 35, tens and singular. So 35, 43, 48, 49, 54, and so on. So this is stem and leaf. So we show data shape using number, tens, hundreds, and so on like that. So one technique that is used to display quantitative information in a condensed form, stem and leaf. The stem and leaf display. Statistical technique to present a set of data. Each numerical value is divided into two parts. The leading digits, tens and single and so on, that is stem and leaf. And quartiles, quarter means 4, so quartiles, the standard deviation is most widely used measure of dispersion, but alternative ways of describing spread of data include determining the location of values that divide a set of observation into equal four-part quartile. So quartile divide data set into 4 parts, and then boundary, first quartile, second quartile, third quartile. First quartile, this is first quartile, so 25% and 75%. The first quartile divides the smallest 25% of the value from the other 75% larger, and then finding the location using this formula Q1 equals n plus 1, n is sample size, plus 1 divided by 4 ranked value. Earlier we did finding median. Then median is finding a median using a formula that is location, not value. First find the location and then associate value is median. The same quartile finding location, physical location, and then that associate value is first quartile, second quartile, and so on. The second quartile, Q2, is the same as median. Formula is Q2 equals 2 times n plus 1 divided by 4. That is the same as n plus 1 divided by 2, because divided by 2 divided by 2, then n plus 1 divided by 2 ranked value. This is n plus 1 divided by 2 is median formula, the same. And third quartile, smallest 75%, larger part 25. Q3 equals 3 times n plus 1 divided by 4 ranked value. There are some rules. When we find median, whole number or 0.5, then whole number, just that number is median. 0.5 to value, add divide by 2, that is median. Similar, almost the same. Rule 1, if the result is a whole number, just that ranked value, that is Q1, Q2, Q3. So 7 plus 1 divided by 4, 8 over 4 equals 2. Second ranked value is Q1 here, first, second, so 20.8 is first quartile. Rule number 2, if the result is fractional half, 2.5, 3.5, something like that, the same as finding median, 2.5, that is middle, so take two numbers, 31 plus 35 divided by 2 is quartile 1, 2, 3, and so on. And then rule number 3, if the result is neither whole number nor fraction half, 0.5, instead it can be 0.75, something 0.75, something 0.25. If the result is 0.75, round up, then third ranked value, so 35. If the result is 2.25, then round down, then second ranked value is quartile. So 2.7, something 0.7, round up. Next, if the result is something 0.25, round down. That is the last rule. Practice problem number 12. It's on blackboard under course material. Okay, this one. Determine the median and the first and third quartile. First quartile, median is second quartile, third quartile. We need a formula. Okay. Here, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, sample size is 20. N equals 20. So first quartile Q1 equals N plus 1 divided by 4, 2 equals 20 plus 1 divided by 4 equals 21 divided by 4 equals 5.25. 5.25. So this one, 0.25 round down, that is fifth ranked value. So this data set sample already sorted from smallest to largest. So first, second, third, fourth, fifth, and so on. So fifth ranked value is first quartile. So 1, 2, 3, 4, 5. Fifth one, 7.59. 7.59. And I will show you answer. Okay. And then Q2 or median, Q2 or median. This answer file is also on Blackboard on the course document. 2 times 20 plus 1 divided by 4, that is the same as 20 plus 1 divided by 2 equals 21 divided by 2. 10.5, 0.5, 10.5. So this middle 10.5, 10 and 11. So take 10s and 11s. 9.45 plus 9.61 divided by 2 is second ranked second quartile or median. So 9.45 plus 9.61 divided by 2 equals 9.53. And third quartile, 3 times 20 plus 1, n is 20, divided by 4 equals 63, divided by 4 equals 15.75. 0.75, round up. So 16th ranked value is Q3. 16th ranked value 11, 12, 13, 14, 15, 16th. 12.71 is 12.71 is third quartile value. Okay. Next one is percentile. This percentile is similar to quartile. To formalize the computational procedure, let LP percentile refer to the location of desired percentile. When you take like SAT standard test, then they give something score that is based on percentile. 10%, top 1%, 2%, 3%, and so on like that. That is a percentile. So if we want to find the 33rd percentile, we would use L33, and if we wanted to median the 5th percentile. So using this formula, LP equals n plus 1, n is the sample size, plus 1 over percentile divided by 100. If we have data like this, 1460, 1471, and so on, then first, okay, let me see, they are already sorted, smallest to largest, so rank is first, second, third, and so on like this. So using formula, excuse me, if we want to find L25, this is the same as first quartile, 15 plus 1, 15 is sample size, plus 1, 25% over 100 equals 4. So first ranked value is L25, 25 percentile. And L75, that is third quartile, 15 plus 1 divided by 75 over 100 equals 12. 12 ranked value is L75, 75% percentile or third quartile. So associate value is 1721, 2205. This is percentile. Next one is box plot. A graphical display of 5 numbers, number summary. 5 number is smallest, Q1, Q2 or median, and Q3 largest. Using 5 numbers, draw something like a box. So we call this box plot. Example, if we have 5 numbers, smallest or minimum number 13, Q1 is 15, median is 18, Q3 is 22, maximum number, largest number is 30, then we can draw box plot like this: smallest, Q1, Q2 median, Q3 and maximum, largest. And then using this box plot, we can describe shape of the data, skewness, Another characteristic of a set of data is shape. The shape. There are four shapes commonly observed: symmetric, positively skewed, negatively skewed, or bimodal. Symmetric, from mean or median, left and right, same size, symmetric. And then positively skewed, long right side, tail, from mean, right side is plus, positive, left side is negative, standard deviation. So, right side longer, positive side longer, so positively skewed or skewed right. We can say this one is skewed right or positively skewed. From mean, left side longer, tail, left side, negative side, so negatively skewed or negatively skewed. Bimodal, there are two peaks. So this is bimodal. Box plot, from median to smallest, from median to largest, same distance. If they are the same distance, then shape is symmetric or bell shape. Looks like bell, so we call this bell shape or symmetry. If box plot looks like this, from median to smallest, from median to largest, longer, from median to smallest, then longer left tail, so left skewed or negatively skewed. From median to largest, longer, then longer right tail, so right skewed or positively skewed. Go back to the example. From median to smallest, from median to largest, longer right side. So this example data shape is right skewed or positively skewed. Describing relationship between two variables. Function y equals a plus bx, then it looks like this. This is intercept here, A, and then slope is B. Anyway, y variable here and x variable. This is independent variable. X is independent variable, y is dependent variable. When x change, then y change. So independent variable, dependent variable, x independent variable, y is dependent variable. If we have two variables, then when we study the relationship between two variables, x and y, we refer to the data as bivariate because there are two. One graphical technique we use to show the relationship between variables is called a scatter diagram. So y and x relationship, something like this, relationship, and so on. Then looks like this. Positive looks like this. Negative relationships, x and y. Positive relationship, negative relationship. Then something like line, strong positive relationship. Something like we can see a line, strong negative relationship. Some scatter, but still looks like this way, but scatter than this one is condensed. So weak positive relationship. This one scattered than this one, but we can see something line with negative relationship. Scatter something more, then maybe there is no relationship, or we can say no pattern. And then this one looks like straight line, but this one we can see something line, but it's not straight, curve. So this relationship is non-linear relationship or curve relationship or pattern. Practice problem number 18. Okay, a sample of 28 timeshares in the Orlando, Florida. 28, sample size is 28. Then find five numbers. Based on five numbers, draw box plot and explain shape of this distribution based on skewness. Sample size is 28. N equals 28. This data already sorted, so we can find the smallest and largest two numbers already. Smallest and largest. The smallest, let's say a minimum number, MIN, is 16, 116. Max number equals 353. And now we need Q1. Sample size is 28. Or you count and then you can figure out how many. Anyway, 28 and 28 plus 1 divided by 4. So that is 7.25. 0.25 round down, so sevens ranked value, that is 1, 2, 3, 4, 5, 6, 7, 209. like this, using formula you can find Q2 and Q3. I'll bring up answer. Okay. Q2 or median 2 times 28 plus 1 divided by 4, that is 29 divided by 2 equals 14.5, fractional half. So take two numbers, 14 and 15. One, two, three, 4, 5, 6, 7, 8, 9, 10, 14, 246, 15 is 60. So take two numbers. 14th is 246, 15th is 260 divided by 2 equals 253. Q3 equals 3 times 28 and sample size plus 1 divided by 4 equals 87 divided by 4, 21.75. 0.75 round up, so 22nd ranked value is Q3. 22nd number is 87654 309 307 22nd 714 21 22nd is 307. So 5 numbers are smallest or minimum 116. Q1 is 7th ranked value 209. Q2 or median 14 and 15, two numbers and divided by 2, so 253. Q3 is 21.75 ranked value, but round up 22nd ranked value 307. Largest is 353. So using 5 numbers, you can draw a box plot like this. Smallest, Q1, Q2 or median, and Q3. From Q1 to Q3, box and median, middle, and then connect smallest and largest. This is box plot. Then shape of this sample set is negatively skewed. Left side or negative side is longer. How can you get? Let me see. Just a moment. I need number. Smallest is 116. Q1 doesn't matter. Median is 253. Largest is 353. Okay. Distance between smallest and median. Distance between median and largest. Okay, median to smallest 253 minus 116, that is 137. And distance between median and largest, 350 3 minus 253 equals 100. 137, that is bigger than this one. So this side, left side is longer. So longer left tail, something like this. So shape looks like this. Longer left tail or negative side. So shape of this data is negatively skewed or left skewed. Negatively skewed or left skewed. So shape of this data, because left side from smallest to median, Q2 is longer, so the distribution is negatively or left skewed. That's all for chapter 4. You have assignment under assignment and week 2. Find the assignment chapter 4 and complete by due date.